Hi everyone! In this video, I'm going to use Starburst Galaxy to show you how Iceberg tables evolve when you make changes, such as renaming columns, adding additional columns, renaming partitions, and eliminating partitions. At each step, you will see what impact these changes have on the records in the table as I investigate how these changes are tracked by Iceberg's metadata files. The final part of this video will walk you through compacting small files into fewer, larger files. This video accompanies the Starburst tutorial of the same name, which you can read through if you prefer written instructions. If you plan on following along, please make sure you've completed the prerequisite tutorial titled Configure a Starburst Galaxy Data Lake Catalog and Schema. In that tutorial, you'll create a catalog that connects to an Amazon S3 bucket owned and maintained by Starburst so that you don't have to worry about bringing your own data storage. Okay, let's get started. I've already created an Iceberg table called Planes that I'm going to use for this video. As you can see from the SQL I used, this table has 3 columns: tail number, name, and color. This table is empty, so let's add some records to it. I'm going to run this SQL here to add 2 records. And then just to check that the records were added successfully, I'll run this select star from planes. Okay, it looks good. Now that we have a simple table to work with, let's talk about Schema Evolution. Schema Evolution refers to the modification of tables as business rules and source systems are modified over time. There are different ways to modify Iceberg tables, which you'll see in a moment. Suppose, for instance, we looked at the planes table and decided that the column we are calling names is more of a description. We can easily remedy that by altering the table. And I'm going to run this command here to do so. It says alter table planes rename column name to description. So let's run that. And now if I query the planes table again, I'll be able to see that the column has been renamed. Okay, great. Let's go ahead and add another record to the table so that we have more data to work with. So I'll add this record here. And now I'm going to use the alter table command again, but this time I'll use it to add some columns to the table. I have 4 statements here to add 4 columns. So I'm going to highlight them all and click Run Selected. Okay. Now let's just check the table again to make sure those changes have taken effect. And they have, that's great. And now I'm going to use the alter table command yet again, but this time I'm going to remove the color column because it doesn't have much value for me. So let's drop the column. Great, and then check the table again. Notice that my changes have introduced a lot of null values to the table. This is a quick fix. I can modify my table again to add values to the new fields. This time I'm going to use the update command 3 times, 1 for each record in my table. So I've got my commands right here, and I'm going to run them one at a time. There's 1. There's 2, and the third one. Great. Now if I query my table again, I can see that everything's been changed. Okay, now let's move on to partition evolution. At this point, my table doesn't have any partitions, but I'll remedy that soon. First, however, I'm going to change the name of my table to aircraft so that I can add records for helicopters as well. So I'll use this alter table command right here. Okay. And now let's add a partition to the table. I'm going to partition it by class. So I can alter the table to partition it. One thing that is vital for you to understand is that when you change the partitioning strategy with an Apache Iceberg table, it does not repartition previously persisted data. So even though we just added a partition to the table, the records that are already in there have not been partitioned, and you'll see proof of that in a moment. Let's add 2 new records for helicopters to the table first. Now let's query the partition metadata table to see what kind of information we can gather. So here's the query that I'm going to run. And if I review the results, I can see the bottom row here shows that 6 records were added when there was no partition. Then the top row tells me that 2 more records were added and what their partition was. This proves that, as stated previously, changes to the partitioning strategy do not automatically repartition the data previously persisted. Let's suppose now that the needs of the business change and it has been determined that analysts are querying across specific years of manufacturing more than the class of the aircraft. Luckily, we can change the partition strategy to account for this. And I'm going to do that using this alter table command right here. And now I'm going to query the partitions table again to verify that this did not repartition any existing data. So here's my query. Okay, so you can see that did not repartition anything. So we've just changed the partition strategy to partitioning by year of manufacture, but we only have one aircraft for each year at this point. I'm going to add some more records to beef up the table a bit. So here are my records, and I'll run that. And now because I added those records after changing the partition strategy, they should have been partitioned. And let's check the partitions table again to verify this. Okay, great. You can see from the results that the 5 new records were added into separate partitions based on their year values. At this point, I've made quite a few changes to my table, and as you'll see in a moment, I now have a bunch of small files that are being used by the current table snapshot. Having to read many small files can hurt system performance, especially in cloud storage. Luckily, Iceberg includes an optimize feature that combines small files into larger ones, ensuring maximum performance when it comes to querying. This is known as compaction. Let's take a look at the files metadata table to confirm that there are, in fact, many small files in there. So I'm going to run this query against the files metadata table. And you can see that, yes, there are a lot of very small files in there. Okay, time to optimize the table. It's a simple command that I'll run right now. Okay, great. And now if we check the files table again, we'll be able to see that there are fewer files. So let's query it. Yep, there are far fewer files. They're still pretty small in size, but the problem has still been greatly reduced. And that's all for this video. Thanks for watching.